Here are some fun facts about equilibrium. What does a very small value of K signify? A lousy yield, typically, it means that the reaction is going forward to a lesser extent than it's going backwards. It's a very low equilibrium. Reaction does not occur much. It's a lousy yield. You could draw a very big backwards arrow and a very small forwards arrow, and sometimes instructors do that to really give you a feeling for what those arrows mean. How do we relate the forward rate constant and the reverse constant? Well, since we set it up as products over reactants, if you had the reverse reaction, they become inverted. So you can say that they have an inverse relationship. How does the value of K vary when the balanced equation is multiplied? That's interesting. Well, since the coefficients become exponents, if you're doubling things, that makes it for an exponential increase. So if you double this, then the new one will have n will be the extent to which you're multiplying it, and so it will become an exponential effect. The units, well, they were weird for rate constants. They depended on the order of the reaction. But for here, there's none at all, so perhaps that's a nice simple thing. Does equilibrium change with pressure or temperature? If you heat things up, will it change the equilibrium? In fact, it will. So just like for rate constants, they gave you the data at a certain temperature typically. Here, they'll do the same thing. They'll give you the equilibrium constant at a given temperature or pressure. And speaking of pressure, can we use partial pressure instead of concentration, K sub P rather than K sub C? Sure, if they give you data, you can just incorporate it just as if it were concentration. Yes, they're called Kp and K sub C. This does not mean they're interchangeable. You'll remember in the first slide, we showed you the relationship where it changes depending on the change in the number of moles. So these are K sub P and K sub C respectively. All right, let's go ahead and do a standard rate equation with the equilibrium equations, and we'll compare them in the next slide.